just explaining, and then we just have 2 more sections, and that'll conclude the circled unit. So make sure you're studying, listen, make sure you're studying every night, even though you didn't have homework on. You had homework on a consistent basis with this unit. So hopefully you're doing what it takes. Remember, this last one's not going to be the easiest. All right, first conjecture. When 2 chords intersect inside a circle, then the product, highlight product, what does product mean? What? It means to multiply, right? So we're going to multiply something here. What are we going to multiply? We're going to multiply the segments of one chord, and it's going to be equal to the product. There's product again. We're going to multiply again. What are we going to multiply? The segments of the other chord. Segments of one chord, multiply them, equal them to the segments, multiply the segments of the other chord. Okay, so you have this right here, which this looks like a picture that of another conjecture that I already talked about. Okay, I'll talk about that in a second, but R, you're going to multiply with what, y'all? U. That's it. So write that down. R times U. And then that equals, where's this from? I don't even know that. R times U equals S times T. That's it. R times U equals S times T. This same picture can be related to this angle, this arc, and that arc. Remember that conjecture? What was the key words? The average. Okay? Or this angle, this arc, and this arc. Same thing, right? The average. So all that right there, this one picture, could be 2 different things. You could be solving for segments, or you could be solving for angles, or you could be solving for arcs. Okay? So see how it's a little complicated? You have to go study. Okay. Next one. Length of intersecting sequence. Give you a second to write that down. And then I'll explain it in the picture. It's always easier when a picture is there rather than 100 words. Alright, so basically this one involves a secant segment. Y'all know secants to be lines. So this is the difference between a secant segment. So here's the line, remember it goes on forever and ever. Well, the secant segment only consists from that point to that point. That's a secant segment. Look at how I'm representing this whole letter. V. Okay. There's another secant segment. This is the external part. I don't know if you've read it. The product of one secant segment and the external segment. W is being represented as the external one. So let's label this one as a secant segment. And W is the external secant segment. Okay, just so you know what is what. Z is the long secant segment, W is the external one. And then same thing goes for the other ones over here. Y is a secant segment, and it goes from this point to there. And then X is the other external secant segment. So this formula goes like this. Z times W is equal to Y times X. Okay, so remember, it's the whole secant segment times the outer part equals the other one. Of course, they have to be connected. It can't be a picture like this. And then just because they're close to each other. Okay, so that one doesn't work. They have to intersect. All right, third one. And that's it. Last one. Deals with the secant segment again, but then a tangent segment. Okay, so this one goes like this. Still dealing with that secant segment. So let's circle that. And you're going to multiply that whole thing with the external one, just like the other properties. So from here to here, that whole thing multiplied by that external. And then it's going to equal, what does it say? Tangent segment squared. Okay, so here's how this one looks. M times N equals what, y'all? So this is kind of, sort of, the last conjecture properties goes. Okay? And then the last two sections deal with radian measure and the equation of the circle. So it's not really like the properties, but there's still two more parts. Okay? Alright. Let's do some examples. Start off with this one. This is pretty easy. This is from the first conjecture. So tell me the formula, or tell me what to write down, Olivia, for this first one. Now tell me the order that you're going to tell me the upcoming step. 4 times x equals what? 3 times x. That's it. Okay? That's how you do that one. 4 times 6 is 24. You're going to divide by 3 to get x by itself. So what's 24 divided by 3 on? 8. So x equals 8. Okay? We'll do a more challenging one that deals with algebra algebra here in a second, because I know those are the ones that you probably need more help on. Okay, the second one on this one. Let's solve for x first. Okay, solve for x first. Tucker, what formula do I use? No, not that one. I'm going to solve for x, not y. The second one, right? So the secant times the external part equals the secant times the external part. So tell me what to write, Maddie. No. Almost, right? Very close. Closer than the last person. No? You're very close though. I'll tell you what, you got the first part right. You said 9 times 4 equals 3 times, and then that's why you got messed up. Mason? X plus 3, right? 100 times 3. Oh, I didn't hear that. I'm sorry, plus. That's what you meant. Okay, so how do you get 9? Remember the picture? It has like that long arrow looking thing. If I were you, I would do some sort of bracket like that to kind of remind you that this is how the formula goes. So this is 9, and then this one over here is what? X plus 3, right? A lot of people, including first period, call that free X. Okay, a lot of people did that before. So remember, when you're doing the whole segment, you're adding those two segments together, because that's how the formula goes. It's the whole thing. Okay? All right, so then we get 36 equals what now? 3x plus 9 minus 9 minus 9. 3x equals 27 divided by 3, and x equals what, y'all? Okay. Now we gotta solve for y. Tell me the formula. Go with Nancy. Tell me the formula that involves y. So, okay. 9 times 4 equals plus 3. That's it right there. Good job. 9 plus 4 equals y squared. So remember, whenever you're working with the tangent, it's the tangent squared. Alright. So 36 equals y squared. That's equal to y. Okay? So just use the formula. Yeah. Why would you use? You can if you want to, but you can go plug in, your name for that, and then do 12 times 3 equals y squared. You get the same exact thing, don't you? Yeah, it doesn't matter, as long as what? As long as they intersect at that 1 point, okay? But yeah, you can use either of the secant segments. Okay, let's go to a more challenging one now. This one is about simple baby numbers, okay? But you still do the exact same thing that we did on the first example. Let's do this one in our head. What's DE times EB? Let's do that one in our head. What do we get? 12x squared. Very good. Let's see how we multiply those in our head. Nope. Okay, you just do 6x times 2x minus 1. Now we see it? Yes. Alright. Equals, now the other one we probably can't do in our head because it involves doing what method? You remember? FOIL. Remember the FOIL method? write it out. 3x plus 3 times 4x minus 5. Remember how to do the FOIL method? Alright, so multiply the first term. What's that? 12x squared. That's the first term. What comes after that? Oh, outside terms. What's that? Negative 15x. Next one is I, inside terms. What's 3 times 4x? And L, the last terms. Minus 15. Y'all remember how to go through one? Okay. Alright, so we have this equals all of that. Okay. What happened? There's something that you should be a little excited about because then it makes the problem easier. Thank you. It's 212x squared, which eliminates it from being a what type of problem? You can write down them in your warm-ups. A quadratic equation. So you don't have to solve a quadratic equation now. It makes life easier. Right? So minus 12x squared. Whatever you do to one side, you do to the other, they cancel out. Okay? Now let's combine my terms. What are you going to move all to the left side with that? What's this, y'all? Let's make it 1. How much? Negative 3x. So if I'm going to move that negative 3x over here, what does it become? Positive 3x. And now it's what? Negative 3x equals negative 15. What is that equal? Okay. Now all you have to do is plug it in. You lost?
Does that say 18x squared?
Where? Right here?
Yes.
No, 12x squared. Because 6x times 2x is 12x.
Or x.
Yeah, I just canceled them out because there were like Okay, so good? Okay, so once we plug in x, tell me what the length of EB is, y'all. 30. Write 30 down. What's the length of DE? 9. What's the length? What's the length of CE? And AE? Okay, so a little bit of algebra that you have to do. All right, let's go to that one. Okay, what should we write down first? Wait. Before I do the formula, I told you this is a good strategy to do. RT by what? No. Now the formula goes. Yes, that's what I want you to do first. Add these two up because we're not going to do RT, we're going to do what? RV. So what is the length of RV? 7x plus 10. So write that down. And then what other one do I want you to write down? Thank you. SB. What's SB? 26. Okay. When you write those two down, then it hopefully will help you remember the formula. Okay. Now the formula goes like what? See what? Very good. Equals. Okay. Good. So the big segment multiplied by the external, and then equals the big segment minus, multiplied the little one. The external. typing? Nope.
I say yeah, but it's a little bit.
Look, guys. That's this one right here. Remember Z times W, Y times X. It's the whole thing times the external part. That's all we did. All right, so we're making FOIL again. So let's do that. First term, just 4 times 7x. Outside terms. Inside terms. And last term. Equals, what's that number? 312? 28x squared plus 61x plus 30 equals 312. All right, we just finished doing this, so what did we do?
Well, I mean, you could.
Where's that going to get us though? If you subtract 30 from both sides. Well, that's what you want to step. Yeah, I guess you could, but then it, you know, then you have to do something else. We just finished solving some quadratic equations in our warm-ups. Not minus 30. Subtract 312. We want to set it equal to 0. Subtract 312, so that way it's equal to 0. So we have 28x squared plus 61x minus 280 what? So what's the whole point of setting it equal to 0 now? We can solve this quadratic equation. Okay? Because what canceled out from the beginning? The x squared. Did any x squared cancel out over here? No. So now this is what I'm saying. Like earlier, I was like, yay! It should be making you a little bit happier because now you don't have to solve a quadratic equation. It's doing it now. You're not freaking out because oh my gosh, I don't know how to solve a quadratic equation. Right? Yeah. We forgot how to solve a quadratic equation. So, anybody remember? What were the 2 ways I showed you how to solve a quadratic equation in the past 3 warm-ups? That'll tell you how many solutions there are. E squared minus 4ac. Remember that? Did we use the quadratic formula yet? No, that's coming up. I also showed you how to do it in the calculator. Okay, so everybody show their calculator and solve it in your calculator.
Hey, quiet down.
Write down. Look on me. So, we all set those answers, negative 4 point what? 4? Okay, and the other one to the right. 2.2 what? 7? Alright, so there's your 2 answers right there. Right, last one. Yes. Oh, I'm wrong. So, if you plug in the negative, if you plug in the negative answer, are we going to get a negative value? Yes. Can you have a negative length? No. So this is the one you want to use right here. Okay. So 2.27.
What is it both possible?
Huh?
What is it both possible?
Then you put both down. You would say this or this. Okay? Alright, so 2.27 times 4 is 0.27 times 4